So a few notes here. 1 byte is equal to 8 bits. Now, the more bits allocated, the more values can be represented. This also means that more bits will require more memory, okay, because again, it's taking up more bits out of the available memory. So this means you have to choose the type, the int type, for example, and we'll get to some of the other types in upcoming lessons, but we have to choose wisely to minimize memory usage. So in other words, use only what you need. There are various types of integers, each with different sizes or that take up more memory basically. So we have the short int, the long int, long int, and then we also have unsigned, so you have signed and unsigned. So signed simply means that there's a plus or a minus in front of it, whereas unsigned is kind of assumed to be positive. It doesn't really have the sign, it's simply a positive value. So each of these has a different size, as you can see. So the short int and the int are 16 bits. The long is 32 bits, and then the long is 64 bits. The unsigned short is also 16, unsigned int is also 16, and then unsigned long is 32, similar to the signed long, and the unsigned long is 64 bits, similar to the signed long. So I would like to note that you can simply write what is in red. So for example, you don't have to write signed short int, you can simply write short. And the reason is that signed, so all of these that are signed are default or assumed. So if you don't write unsigned specifically, then it's assumed to be signed. Now we do have to be explicit when we do want unsigned variables. So here we have unsigned int, for example, or unsigned short. Again, in this case, we are explicit. You can write it out like the full line if you want. It's kind of a synonym. But of course, you can shorten it to simply the red. So short int, long, or unsigned, short, unsigned int, and so forth. Here we can see the size in bits and the amount of values that we get on the right. And the formula for this is 2 to the power of how many bits. So in this case, if we have 8 bits, we can do 2 to the power of 8. And that means we get 256 values. And that is the typical size for a character and is useful to represent 256 characters. All right, so if you want to do an alphabet, you can store 256 values in a character. So for the Latin alphabet, for example, okay, the Latin character set. All right, so why do we care about all of these different integer types and all this stuff? You don't really want to be dealing with this like I just want to write a program, right? That's what you might be thinking when you are new to all of this stuff. Like, why can't I simply do int? Well, it's important to realize again that C++ provides us with flexibility and low-level control over, again, managing memory and stuff like that. So you might want to write in some other programming language, where you don't care about this stuff and just like write your logic for your program. But this stuff is kind of important because, as I explained in a lot of detail in the previous videos, we store our variables in RAM, right? And in some cases, such as when we have embedded devices and so on, we have a limited amount of processing power as well as RAM and storage. So you want to make sure that you select the variables and stuff that makes sense, right? You don't want to use too much memory. Also, it's important to note that when you multiply stuff together and you store the result in some variable, you might get an error, so an overflow error or problem with your code. You might get some value that you don't expect. And we'll take a look at an example later in the video where you might have two variables, you multiply those together, and you expect the value to simply show up. The correct result will show up as you expect. But it does not, and that's because in some cases you'll have values that are simply too large to be stored in that variable location, okay, that location in memory. Because again, when we declare a variable, we give it a specific type, and that type defines or specifies to the compiler how much space it has to reserve for that specific variable. And Of course, if you use a long to store age, a simple age variable, that's kind of overkill, right? It's kind of silly. You're kind of wasting space in memory. Similarly, it does not have to be signed. It can be unsigned because we don't have an age of -10 or something like that to have like positive, right? So in that case, we can have an unsigned integer. And also, again, when you want to store huge values from kilometers, for example, from one planet to another or so forth, you can have problems storing those values in certain integer types because the amount of bits that you have cannot represent that value. So you have, again, a bunch of ones and zeros on your actual computer, right, that has to store these values. And you need more and more of those bits, so ones and zeros, to store larger and larger values. But of course, the more of those that you store, the bigger like space or chunk in memory that it takes up. So you have to choose these wisely. And yeah, it might seem like a bit of extra like work that you don't want to concern yourself with really, but again, it provides you with that control, which is important. Also, for the most part, you can just like try and use int. Okay, so for the most part in this course, we'll be using int. So you don't have to like memorize every single detail of all of this stuff, but ultimately you do have the stuff available to you. It's not just a simple like int and it has some predefined stuff. Like you can choose like what you need to store bigger or smaller values. Okay, so that's a very useful feature set. So here I wanted to show you some of the value ranges that you get. And so I kind of partner these up. So we have signed short int and unsigned short int here right at the top, for example. So the value range for the signed short int is minus 32,768, for example, to 32,767. Now the unsigned short uses the same amount of bits, right? The same amount of storage space. But here we start at 0. We don't start at that minus. So this means that we can go to 65,535. This simply means that we can, if we have positive only values, then we can use this and we can store like a bigger value in that compared to the signed one, where we have to think about not just positive values, but also negative values. Then we have signed long and unsigned long int. As you can see, basically these get bigger and bigger, right? The more storage we have for it, as I explained previously, the bits. So as we explained to the compiler, whichever version of these integers that we are using, it will reserve more space. And as you can see here, the value range becomes larger and larger. So we can store larger and larger values in that predefined space. So we have this operator or function that determines the size in bytes of a type or variable. So in other words, we can use this and then give it a type or a variable that will then return the size in bytes. So the value range for a type depends on the compiler or platform, so your system. Okay, so it's important to realize that this is specific to your compiler, so the underlying architecture. Okay, so the value range might be different on your machine, like if you run it using the sizeof or something, it might give you a different result. So the standard for C++ does not specify the size for the types. It only specifies that a given type, such as double, must not be smaller than the type that appears above it in the type hierarchy. Now we'll talk about more of the other types, such as characters, floats and doubles, and all of that as we go along. Sizeof also returns a number of bytes used to represent objects and arrays, and we'll learn about this in more detail later. So it's very useful. So here are a few examples. So you can do sizeof and pass it a type, such as int, for example, or you can do size of a specific variable. So you give it the identifier, so you pass it the identifier, such as age, for example. We'll look at a simple example in Visual Studio shortly. In the last example, you can see that we do sizeof and then the variable identifier, so without the parentheses. So again, when it comes to variables, you can simply use it this way. You don't have to pass it into parentheses. And again, these are like functions that returns something. So previously we looked at functions that do not return something. So in this case, if you pass it like this, it's similar to the main function. Since it is not void, okay, the main function returns an int and we return 0. But here it's going to return, depending on the type, okay, it's going to return certain values. And to keep it simple, we'll simply print those values out as an example. Okay, I'll start from scratch here and I'll do simply short. So you can see I'm not writing int or anything, I'm simply doing short. And I'm doing something like this. So before I actually use that, I'll do sizeof, and here we can pass it either a type or a variable. So in this case, I'm just going to pass it short. So we can kind of forget about this here for a second. I'm just passing this here. So it's going to take a look at what the size of short is, amount of memory that's required to store this type of variable. So we simply print this out. So this will return, in other words, it will calculate that, and this here will then be replaced by whatever that value is. I'll just build and run that, and the size of short on this implementation is 2. Again, that is in bytes, so that is 16 bits. I'll close out of this, because again 8 times 2 is 16, right? So in this case, let's do long. I'll build and run that, and you'll see we get 4, and so on. You can of course do long as well. You can see 8, so that will be 64 bits. That is, here is in bytes, right? Now a char for a character, that will be 1. So yeah, I should have changed that, but a char here is 1. Yeah, okay. So that is 8 bits. We'll talk about this in more detail later. So what we can also do is this, my variable short size here. I initialize this to 0, so we have some value in there, and I'm going to uncomment that. As you can see, we can also pass variables in here. This will give us the size of this variable, and that should be 2, as you can see. Of course, you can also do int if you want, so this one is heavily dependent on the system. Okay, so here you can see int is 4, we've seen that a short is 2, and so on. So we also have climit and cfloat, which will describe characteristics of integral and floating types, respectively, for the specific system and the compiler implementation that is used. Again, it's important to note that these things are compiler and system dependent, basically. So if you use a different system or setup that I use, or different compiler, you might get different results. You might have different precision values and a different range, for example, and stuff like that. The includes also provide constants, which can help us determine the precision of our primitive types, such as int max, for example, which shows us what the maximum value is that we can store in an integer variable, okay, on our specific machines. And we'll take a look at an example here shortly. Next, let's talk about what is the minimum or maximum size that I can store in something, so such as a short as an example, and how I can see that. So here, what I'll do is I'll just go then what we can do is we can write this. So you will see that these will show up in the IntelliSense. We want short min, for example. This is actually value. Okay, so we want the minimum and maximum values that we can, so the value range basically, okay, that we can store in a short. Control F5 to run this, and you can see that of course this will be negative value because we don't start at 0. This is not unsigned. So min value for a short is that. Let's do max value for a short, and you can just rename that, so short underscore max. You don't need to have this here, by the way, but we'll use that again shortly. Control F5 to run this, and you can see what we get. So that's 32767. So we'll write that down somewhere in case you forget what it is. 32767. I'll close out of this and we'll uncomment this here. Again, you can use these buttons up here as we've discussed, so you can comment or uncomment. What I want to do now, I'm going to print this here. Now first I want to change this to some value. So I'm going to change this to this here. You can just copy and paste that actually. Yeah. And in that case, I want to write this out. So I'm going to Control C again, Control V, and then we want to change this. Of course, you can choose a better variable name here probably, but yeah, I'll just run this and see what we get. So this will give us the value that we stored, of course, is going to go in to that variable location. It's going to go into that container basically, look what's inside, and then basically paste that value or replace this variable here with that number. And of course, we initialized short size here to this value. Okay, so you should be familiar with this stuff by now. So let's change this value. What happens when we, push the computer just a little bit? Well, we'll do that and run this again. And all of a sudden you see we get a negative number. Now in this case, it actually shows us the value here correctly, but we have a minus. So let's do this to, let's say 900. Control F5 to run this. And you'll see in this case, the value is way off. And this will continue to give you weirder and weirder values. Like in this case, you can see it's not nearly that value. Like here, you can see I'm getting a negative value again. So it has to do with overflow. It does not have enough bits available to store a huge number like this. But if I replace that value, increase it like this, again, it'll give us a weird number here. But I can always go and change this to an integer instead. Okay, Control F5 to run this. And now we'll get the right number, the correct number, because int can store this value. This is not too a big number to be stored in an integer variable. So again, we specify a particular type that we give a name, and the type that we give, that we specify for a variable, will determine the range of legal values or numbers that we can store in that location. So I'll just change this back to short. So we are, for that reason, explicit in C++, telling the compiler what variable type we want. We have floats and doubles and all that stuff that we'll talk about later as well. But also we can break that down even further and then go and specify how much space with an integer, which is a whole number, for example, how much space we want. And you can also do unsigned and so on. We'll just initialize it like that. And we'll do two shorts here as well. And then we'll multiply those. So we'll initialize short size. We'll do x multiplied by y. In this case, I'll just rename this. And then paste my short in here and in here. Okay, so we start with x, y, and then we initialize another short here called my short to x multiplied by y, and then we print that out here. So I'll run this, and you can see, of course, that we get a value like this, which will not be the correct answer because there are no negative values in there. So again, we have what is known as an overflow error, which again has to do with the fact that we have a larger value stored in this location, or we are trying to store a larger value in this location than what can be stored in that location, because physically we only have so many bits available in that area. Okay, so I'm just going to close off of that. I'm going to change here to int here as well. Change those to int. Control F5 to run this. You will see that because integer has more bits available to it, again, it can store that number, and this is the correct value. Remember that we can only store up to this, so positive at least. You also have the negative side when it comes to shorts, but this is again what we can store in a short. So this value is too large, so change it to an int and then it works. So you have to keep this in mind, like when you are doing things like this, when you are multiplying things, for example, and you want to store the result in another variable, again, you can get all kinds of problems. So you have to make sure that you use the correct type. Now, of course, this might seem that, okay, well, I'll just use int all the time, but int will be overkill for something like age. So when you do an age variable, then of course a short will be more than enough, because nobody's going to get this old. Well, at least not yet. Okay, you might be wondering, I talked about C limits, but I did not use it previously. So for example, I'll do a short. We can do U short max, for example. Now again, remember that with the short, this was what we could get in the positive. Of course, you also have a negative side to that. So in this case, I'll just control and run this, and you'll see this will be a much higher number, 65,535. So I'll close this off. And now, of course, we can do like that. This will print out because 45,000 fits within that. So we have about a value like that. So 45,000 will fit into that. So I can do myInt here. But before I do, I'd like to talk about these includes. So previously I talked about the C limits. Now what you'll see is I'll comment out IO stream, and then you'll see we'll start to get some errors. So cout, for example, it's undefined, same with endline and so forth. But this here for some reason is defined, and that's because again we have C limits. Now if I comment C limits out, you'll see we get an error here too. It's also not defined. But if I uncomment the IO stream, all of those squigglies go away. So this is basically defined already. Does not show undefined, and it works as we've seen previously. So if that bothers you, you can always include the C limits to have C float for floats. So I'll just include that over there. And of course this will work now. Control F5 to run, and you'll get that value. Okay, so what I'll do is I'll replace that with myInt, and I'll rename this actually something like that. Control F5 to run this, and you'll see that the number, again 150 times 300 here, will give us 45,000, and this short here will store it properly, and that is the unsigned short. The regular short will not be able to store this value because it also has to store negative values, so it only has space for that many values basically. Alright, so I hope that makes sense. Okay, so here in the Microsoft documentation, we have the C and C++ integer limits, and you can see the constants here. Now these are basically like macros, which we'll talk about later. They are kind of like a chunk of code, and so these are basically those macros, and they are called constants here, but I believe the functionality is really defined by some kind of a macro. Okay, so here we can see what we get. So you have unsigned short max, short min, you have long min, long max, and so forth. I'll probably do some kind of an appendix for this stuff. You have values here, okay, the value ranges that you can get from there. So short min, you have minus, again, 3, 2, 7, 6, 8. And short max is what we had. So I just wanted to show you that like you have a bunch of those constants. Okay, in the Microsoft documentation, you can see I have a bunch of these fundamental types. You have category, for example, it will show you integral, and then here you have char, bool, and so forth. You have floating point, and we'll talk about floating points later. Now, I would like to mention, since we are talking about integers in this lesson specifically, you can see that you have a bunch of these here that are kind of weird. You have underscore int 8, underscore int 16, for example. So you have int n, where n is the size in bits of the integer variable. These are Microsoft specific keywords. Again, you have different compilers, and depending on the compiler you use and the platform, so again, not available on all architectures. Okay, so it all depends again on your compiler, the architecture. So down here you can see again the different types. So you have character, for example, 1 byte. You also have something called bool for true and false value. We'll talk about that in more detail later. And then you have other things as well, like the long that we've seen already, which is 8 bytes. All right, I think that concludes this. I hope you learned something here, and I'll see you in the next video.